Hello everyone, my name is Kwame, and today I'm going to demonstrate to you how to build a machine learning model and deploy it with Streamlit. Streamlit is a Python framework that is used to create interactive applications, and in this case, we are going to wrap our machine learning model around the app to make it easier for users to interact with. So for our environment, we are going to make sure that we have Python installed. We are going to need our Jupyter Notebook and the dataset for the work, and then we are going to be sure that we have Streamlit also installed. So the dataset we are going to use for today's work is an insurance prediction dataset, where we are going to use about 12 columns available to us to predict whether or not a building has a claim over an insured period. So for a brief walkthrough, we have data on the customer ID, the year of observation, the insured period, whether the building is residential or not, whether the building is painted, fenced, whether it has a garden, the kind of settlement where the building is, what the building dimension, the building type, the date of occupancy, the number of windows the building has, the geographical code, and the target the claim. That is whether or not the building has a claim or not. So we begin by loading the key toolboxes, the key items that we are going to need. That is pandas and numpy for data manipulation, seaborn, plotly, and matplotlib for our visualizations, and then the scikit-learn libraries and modules for our prediction. We're also going to want to import pickle for the export of our machine learning items. So for the dataset, we import the dataset, and for a quick walkthrough, since we are not going to use the customer ID column, we drop it and then look at a quick info of the dataset. We notice we have a number of data types from integers, floats, and then objects. We also note a few columns have some missing values. So we check how many missing values are in the various columns so that we know how to act on them. We check for duplicates, and then we also know that we have a few duplicates. We look at for the columns that have missing values, we take actions on them by using the simple imputer to impute the missing values. We do a quick exploration of the numeric columns to see the distribution of the data that we have by whether the claim type. We also look at the categorical columns and see the distribution of the categories in the various columns. We see that the geocode has lots of different values, right? And so similar to the ID column, since they are unique to each observation, we are going to drop it. For number of windows, we would ideally expect that as a number, but we see that as categorical, and so we understand why it's categorical because of the greater than and equal to sign, and then because of the dots. So we fix them by we cap the number of windows at 10, and then we replace the observations with no values with the mode for that column. We quickly look at the unique values in each column, the various columns, so that we can see how we're going to go by encoding. We are sure that we want to be satisfied that all the missing values have been dealt with. We create a list for our numeric columns and the categorical columns to help with our encoding, which we do with the one hot encoder. And then we take a quick look at the correlation matrix to see the relations between the columns. We notice that a building having a fence, having a garden, and then the settlements in which they are highly correlated, right? So we go on to our modeling, and since the data set is in balance, that is, those that do not have a claim being much more than those that have a claim, we want to balance it. And so we use the smooth sampling strategy to balance it to be sure that the model learns as much as possible. We scale our numeric values using the min-max scaler, and then we create a dictionary of our models, right, to have our modeling and evaluation at a go. And so we create a function to do our modeling and evaluation. We have our logistic regressor whose performance is quite good. We have a decision tree model. We have a random forest model. We have our XG boost model. We have our CATS boost model, and then we have our light GPM model. So we compare their performances, and then we note that our XG boost model is the best. And so we are going to do the final prediction on the data, do the prediction on the test data, and then we are going to export for building of our app. So we load our test data here. We take a look at its shape and its information. We note that it has some missing values as well. So we repeat the actions we did on the training data by dropping some columns and then fixing the number of windows column, and then working out the other columns, that's imputing the missing values. And then we create a list of our numeric columns again. We encode the numeric columns, and then we encode the categorical columns, we scale the numeric columns, and then we do our predictions on the test data, right? So then we come on to export the key items that we use in the data set, the modeling. So we export our requirements file, which will contain the key modules and libraries that we use for the work. We are also going to encode the key items that are encoder, our scalar, and the model. So we create a folder called SRC and then export these items using pickle, right? So that we can embed in the app. We also export the model using the XGB save model method. So next up, we move straight into the VS Code so that we create our app and then wrap the model around it. Okay, so we continue in VS Code. First, we create a new file and then name it app.py. Then we can create a virtual environment and then install our requirements, right? So as the virtual environment is being created, we are going to create the interface of our app. But we first begin by making the key import. So we load key libraries and modules. So we are going to load key libraries and modules here. As we wait for the terminal to load, we are then going to set the page configurations and a few introductory information. So st.set page config. We are going to have page title is equal to insurance prediction app. We are going to have initial sidebar. We are going to have a sidebar. So we are going to set the sidebar state. We're also going to, so let's instantiate our virtual environment here. Yeah, so as a virtual environment and the requirements install, we are going to set the page title. That's the title that's going to be displayed at the top of the page. So Streamlit title. We are going to have insurance claim prediction with machine learning. We are going to import the item. So we notice that in our files, the requirements file has come, and then the toolkits that we exported are in the SRC folder. So we are going to want to import them quickly, and then we are going to move straight to creating the interface, right? So we create a quick function to import the toolkit. We create a function to import the toolkit and cache it. We also create a function to load the dataset and then preview it for the user. We are going to import the components that we exported and then move on straight to the interface before we go on. So the process for the interface, we are going to set containers that we are going to use in our work, right? So we are going to define the app sections that we are going to use, and from the app sections we are going to build the interface that the user is going to interact with. So let's begin by defining app sections. So the base containers, we are going to have a header, which is going to be a Streamlit container. We are going to have a dataset section, which is going to also be a Streamlit container. We are going to have a section for features and output, which is also going to be a Streamlit container. Then we may probably want an icon for the page, but we are going to skip that for now. We are going to instantiate a form to receive the inputs from the user, right? Then so we instantiate our form with the Streamlit form. We set the key, that's what's going to be displayed as information. Then maybe we are going to clear the form whenever the user clicks submit. We are going to set it to true. So we are going to structure the header section. So header section, let's make that quick using a with block. We are going to structure the sidebar. So we interact with the sidebar using st.sidebar, and for the header of the sidebar we are going to say information on columns. Then we are going to create a quick markdown component to bring in the data dictionary that we saw in our notebook. we do that, then we structure the dataset section also using a with block. So we are going to have with datasets. We create a checkbox for the user to preview the datasets, and then we load the dataset for them to take a look at the head. That's the first 5 rows of the dataset. We define a list of expected variables where we are going to just bring in the lists from the notebook that we created quickly. We are going to structure the features and output section next. So we'll structure the features and output section. So we notice that our virtual environment is done creating, and so we can move on straight after creating the interface to just take a preview of the app. So in the features and outputs section, we are also going to use a with block, and we are going to first create a sub header and then caption it input. We are going to also add some text to tell the user that this section captures the inputs to be used in predictions, right? Then we will go straight to uh, create 2 columns. So we want to create columns to receive the inputs from the user, right? So we're going to have features that and output, and then we have 2 columns. Let's quickly bring in the columns for the inputs, right? Let's create for about 3 of them. So for the left column, we are going to have, so design the input section. So still using the with block and then referring to the form that we created earlier, we are going to say that in the left column, let's add some markdown text and then say that input set 1 with the colon. Then we can begin with the year of observation. We are going to still in the left column, we are going to take a number input. Since the year of observation is a number, we are going to take a number input, and then we are going to bring the label that selects a year for the user to select the year, and then we are going to set the minimum value to the value in the data set, let's say 2012, and years move in ones, so we set the step to 1. We are also going to bring the insured period, which is another column in the data set. So still in the left column, we are going to use a select box, which is like a drop down. So insured period, and then let's quickly add the other components, full year or half year. Then we are going to bring in our options as a list 0.5 and 1. Then let's quickly do same for all the other components or the other features in the data set. So for each feature in the dataset, we are going to create a component for them to receive their inputs, and then we are going to bring in the submit button, right? So after bringing in the submit button, we are then going to process the inputs received from the user. So process inputs from user. So we are going to have, still using the wait block, with if the user submits, we are now going to have, still with the features and outputs, we are going to format the inputs as a dictionary and then convert them to, we are going to format the inputs as a dictionary, convert the dictionary into a data frame, perform our encoding, join the encoded categoricals back into the main data frame, scale the numeric columns, and then we are going to format the output, and then we are going to display that output. The user may want to store the results that they have, so we'll quickly add another component to let them set the display and then create a data frame for them to store their results. So now that we have this in check, we want to quickly look at how the dataset looks like, how the app that we've created looks like. So back in our browser, we can preview the dataset here. We can see the dataset, first few rows of the dataset, and then we can test our app here. you can change the inputs and then test the app as desired. Right. So we can then move on to deployment. We can deploy with the Hugging Face cloud, the Streamlit cloud, or the Hugging Face spaces. So today we are going to deploy with the Hugging Face spaces. So you go to Hugging Face, you log in, you create a new space. Let's call it insurance claim prediction. You click Streamlit, make it a public space. You click create space. Then you can bring in the files that you need for the app. Right, so you go to files, then you click add file, you click upload files, then you can go to you can bring in the files from the app from your file explorer directly. So um, insurance prediction loading. So in the upload files, you can bring in the key files for the app, wait for them to load, then you can commit the changes. Wait for the Hugging Face to complete with the uploads. So with the uploads done, you come back here and we'll quickly want to make a few changes to the app file. Hugging Face treats the dashes differently, so we want to reverse the slashes where we have them, and then we can commit that change. You commit this change. Committing this change, you come back to the app and then you see it building. So you wait for some time. Yeah, so once it is done building, you close the interface and boom, you have your deployed app, right, with Streamlit. So you can change the inputs and then make your predictions as desired. And you can look at the previous predictions that you've made also here. So basically, the process of deploying an app to Streamlit involves building a model, machine learning model, exporting it from your Jupyter notebook, building a Streamlit apps interface, embedding the machine learning model, and then deploying it to your desired platform. That could be your Hugging Face spaces or the Streamlit cloud. If you want to learn this and then many more like this to make impactful decisions in organizations, be sure to check out and join the Azubi Africa Data Analytics program. Thank you.